Terrestrial biodiversity fauna. Objective. This study aims to gain knowledge about terrestrial biodiversity fauna through the use of GIS. Introduction. Fauna is a term which refers to all of the animal life with a specified region, time, period, or both. Fauna was first used as biological term by naturalist Carl Linnaeus as a term which described the animals of a region as opposed to the plants. Linnaeus seems to have borrowed term from Greek and Roman mythology. Terrestrial fauna, the aggregate of animals that inhabit dry land. Terrestrial fauna comprises approximately 4/5 of all the Earth's animal species. This large number is explained by the greater variety of living conditions on land than in the watery environment. The many sharp changes in the geological history of land, for example in climate and relief and the isolation of continents and islands. Methodology. Biogeographers are continuously researching methods to map species distribution and diversity that can have significant application for conservation planning. Exhaustive ground surveys and inventories of species in field are the precise way to accumulate biogeographical data on species distributions. However, such ground-based methods require skilled individuals and significant amount of time in the field, making them highly expensive. Also, even for relatively well-studied areas, different field data sources can lead to dissimilar or biased result of species distribution and diversity. Conclusion. The potential capacity or systematic observations at various scales, remote sensing technology extends possible data archives from present time to over several decades back. Also, it is not as labor intensive and time consuming as the field observation based studies. Remote sensing has considerable potential as a source of information on biodiversity at landscape, regional, continental, and global spatial scales. Satellite remote sensing's process of obtaining information about Earth from space and then effectively processing it was swept the field of biodiversity conservation and its management in recent years. The latest advances in RS technologies strengthen its use in capturing measurement of biodiversity on Earth and in addressing in in situ and situ biodiversity.